Now let's look at the hardware hack. I'll show you the surprisingly simple process of modifying the monkey so we can control him with an electronic circuit, as well as how to wire up the components and the board itself so that it all works together. The hardware hack for TweetMonkey is really very simple. The first thing I did when I brought this gadget home is I inspected his battery bay and figured out how his existing switch works. It's a really simple mechanism. The switch on the outside of the battery bay slides back and forth, alternately connecting and disconnecting the conductive connection between the two batteries. So you switch it one way, the batteries are not connected. It's an open circuit. You switch it the other way, and the batteries are connected. It closes the circuit, just like pretty much any electronics project we know. Now all we need to do then is tap some wires into these metal contacts that you can see. And then connecting those two wires together will essentially bypass the switch and let the current flow. It will close the circuit by way of an alternate path, and that will animate TweetMonkey. Now as a bonus, the original switch still works just like normal, which is good for showing off TweetMonkey's basic functionality when you don't have things wired up yet. I just used a small drill bit to drill 2 holes through the bay door and led 2 small gauge wires through the holes. Just a touch of solder permanently created conductive connections from each of those wires to each of those battery bay contacts. Now, if you're intimidated by or under-equipped for soldering, you can instead go to your local Radio Shack and you can buy some conductive glue. A little dab of conductive glue and a little time to dry, and you'll have a functional equivalent of a solder joint. Once these connections are made, all you have to do to make the monkey move is touch the 2 wires together. That bypasses the built-in switch and completes the circuit. Now we're going to implement a little device though that does this according to logic. The component that we need for this job is called a relay. A relay is an electromechanical device. That means it's both electrical and mechanical. When you give it a little bit of electricity, it mechanically closes another circuit inside, a circuit that usually is capable of carrying a lot more current than the first one. The advantage to a relay is it can act as a bridge between 2 isolated circuits. This monkey doesn't carry a ton of current, but even if it did, we'd be able to drive it with our little 3.3 or 5 volt logical voltage levels and really small amounts of current. In fact, the relay we're using here is made for 120 volt house wiring. You wouldn't need such a capable relay, but that's what I had laying around. I had what's called a Grove Starter Kit by Seed Studio. That's Seed spelled with 3 E's. What you see here is a base shield by Seed. It snaps onto any Arduino board using that standard pinout that we talked about, and then it makes it easy to plug in all the components that come with this Grove Starter Kit. Here's the relay, and here's the jumper wires that make it easy to plug the relay into this base shield. Now all of a sudden the relay is connected to the Edison, and we didn't have to do any soldering or any wire twisting at all. Here's the whole mess hooked up together on my messy project desk. Now if you're really into IoT, by the way, it's required that you have a messy project desk. Now this is a standard everyday USB battery pack, nothing special. Remember, the Edison dev board can be powered by a micro USB, which makes it really convenient. Here's the Edison on its dev board with the Grove base shield installed, with one of those jumper wires connected to the relay and wired into TweetMonkey.